We come now to this concept of modules in Python. And we've been talking up to now about classes and functions. And a module allows us to create a collection of classes and functions in some kind of rational way. So we can package our classes together and we can then distribute those classes. So we can share with our various projects the same module. So if there are classes we write and we often use those classes, then we can create a module and make those classes accessible by other programs we might be writing. Equivalently, we can also share those modules with other people. So we might be working in a team of people, or we might want to share our code out across the internet into the open source community and people like that. Equivalently, there are many modules out there that really make life much easier for us in building the things that we want to build. So in fact, most of Python resides in the modules. It's actually quite difficult for us to get anywhere in Python unless we understand modules and how to use modules. And it's really a surprise to me that I've been able to get to video number 8 in the series without really getting into modules. I think we touched on it a little bit in the looping video, but really we haven't made real use of modules to now. And really even basic operations like working out the sign or the exponential of a number, that happens through a module. And the reason that it's set up this way, right, in most programming languages, we can reasonably expect the exponential of a number to be available without having to load some external module. And the reason in Python that this is done, it's because Python is often used in what we term the production environment. So in a production environment, you really want to optimize your space. In production, you are actually exposing your software to use by potentially tens or hundreds of thousands of people. And so we really have to fight for that last kilobyte of memory, and we really want to reduce the memory usage and we want to increase the speed of our code. And so we want as little overhead as possible. So the way we accomplish this in Python is by segmenting our libraries of code, or segmenting our code into libraries and loading only the absolute minimum that we need for the application we are creating. So we want to create our classes and functions. And of course, a module is accessible in many ways. So I've mentioned using modules by ourselves and our teams. But like I've mentioned, in the open source community, there are many modules available. So if you can imagine some kind of functionality, in some general way, if we can abstract what we are trying to do in some general way, there will exist a module for it, right? There's a large enough Python community that modules are available for almost anything you can imagine. So this is a rich community to work with, and spending even a little time trying to understand what modules might be out there for the problems we're trying to solve really yields very strong results. So we really regard what we are looking at today as a kind of opening point to quite a large body of knowledge. We will also look a little bit beyond Jupyter notebooks. So the real power of Python becomes exposed when we start moving away from the Jupyter notebooks and operating closer to the metal, operating closer to a server. But anyway, let's look at that. So the first thing we'll do is extend what we did in the last video. So let's open up our classes work. And here we had created the animal class and the bird class and so on. So let's copy for ourselves now the animal class into what we'll create as a module. Now, to create a module, we will switch over to an editor. And I like to use Sublime Text, but you can, of course, use whatever editor you like. And here I've created, or I've just pasted in animal. Well, in fact, let's not use this. I want to start from scratch. So I'm going to go create, I'm actually going to start a new instance of Sublime Text, and I want to copy this class animal. So I'm not copying this part here where I'm actually running and using the class. I'm just going to copy the class itself. So I'm copying the animal class, and let's save this. And I'm going to want to store this in the same folder that we're working in. So here, programming with Python, so I'm going to save that here. And when we create a new class, we want to save it with a name and .py. So let's call this class class animal .py. Excuse me. So we've got the animal class in class animal.py, and now if we want to instantiate, or if we want to make use of this animal class, then we have to load that up and we have to import that. And the way we load up that module is by specifying the name of that class. So, the name of that module. So we've named this module class animal. So class animal, and our animal class must be referenced. So let's look here. We've got class animal. Let's also add a function to this. So let's say function is say hi. So say hi will just print out hi. And so we expect that the module class animal, which contains the animal class and the say hi function, we expect to be able to use say hi. But if we just go ahead and ask to say hi, you see that kicks out an error because say hi is not defined. Say hi exists now in the context of class animal. So we have to reference class animal, and now we see that runs. So that's the syntax. Number one, you create your module, and you see it's just this. There's no other code we have to do to specify this is a module. So in contrast to other languages, you might see module.exports and things like that. In the case of Python creation of modules, you just go ahead and create your class and your function, as many as you like, and then if you can load this module, you have access to these classes and methods. So here, import class animal. So we just specify the name that we saved this module as. We just specify that name, and then we are able to call on that class or that function. So we can see say hi worked. Again, if we want to create the cat, so if we say here cat equals animal, and just to make that different, let's do it like this. So of course this is not going to work because we didn't specify the namespace, right? So we need to specify class animal dot animal. So that's the reference to the class. So that's going to instantiate for us Kitty, and currently Kitty doesn't say anything when we instantiate it, so there's no output for that, but there's no error either. So this has worked now. We are able to use that class. Okay, and moving on. So I've got the animal in there, and so walk to and so on should work. So I'm just going to change this a bit here. Right, so all this runs, and you can see here there's a bit of extra output. So that's trying to tell us the memory location of of this object. And so we can suppress that unwanted output just by using a semicolon at the end over there. Right? Okay, so that's the basic syntax. That's how you create a module in Python. Now, there are a couple of things that we can do to refine the way this module will load. We can provide an alias for that module. So fine, we know the file name is class animal, but possibly we don't want to include that class there, or it's often the case that the way that we save something on the hard drive might be different to the way that we want to refer to this collection of things. So the way that we get around that is by using the as keyword. So if we say import animal class, class animal, import class animal as, let's say, animals, then even though animals doesn't exist within that namespace, right? You can see we've never used anything called animals here, and animals is not in the name of that module. Still, we have created an alias here. We say import that module, but then go on to give it the name of animals. So we've renamed the namespace for that module. So now animals can say hi. Right, so we can rename the namespace for the module. We can also reference a different folder. So let's say we maintain a different directory for our repositories and our libraries. So let's say we created a different path here. So I'm just going to make a new folder. So call it path 2. And let's just copy our animal class into path 2. Right now, we are running in this folder, right? Programming with Python, and the module we want to reference exists in path 02. So to reference that, to be able to access that, we have to instruct the Python compiler that among the paths that it should search, please add to that list this new path 02. Right, so to do that, there is a different module. So that's a built-in module, the sys module, system module, I guess. And the system will contain, for one, it will contain the environment variable. So it will tell the compiler that our code, don't only look for the code in the current folder that we are working in, right? In this folder, don't only look in here. There are a bunch of other paths that you can also look in, and those will include built-in modules, such as the one that contains the system module as well. So if we want to add to the list of paths that the compilers should search, then we can go here, system sys.path append. So add to the paths our new path here. So path 02. And of course, this is not the full path name. If I click here, you can see that's not the full path name, but if we specify it this way, then it's working on relative paths. So relative to the current folder, which is here, relative to this folder, look in path 02. So add that to the list of paths to be searched. And once we've added that path to the list, then we can add any modules that are also in that path. And I'm just going to name this one differently so that it doesn't seem like it's only finding class animal because it's already in our current folder. So we are instructing it now, please look for class animal 2. And we are also saying save it as Annie2. And we are looking for say hi. So you can see that works, right? We've added this new path, and we've imported the module, which we've renamed here. We've imported that, and we've used the alias to access the function that's in there. Okay, so that's the second part, right? In terms of other module loading options, we can specify a different folder. The third thing we can do is really get fine-grained and import specific parts from the module. So like I mentioned earlier, when we are working in a production environment where we anticipate heavy use of our application and of our code, then we want to minimize the amount of memory that our code needs. And so we might not want everything that's in a module. If it's an extensive module that contains many, many classes and many functions, and we don't want everything, we want some specific parts of that, then we can specify that. So we could say here, well, I only want say hi. I don't want animal. I don't need this whole class here. I only need this function. And to make that work properly, number one, let's make a new instance of this again. Well, let's do it this way. So I'm renaming this, and let's make this class animal3. And let's open this. Well, I'm not making any change to this, that's fine. So that's class animal3. So I'm going to open up class animal3, save it as any3. But now when I import this, I'm going to specify that I only want say hi from there. Or yeah, okay, let's say we only want that. So the way we do that is to say from class animal3 import, and then we specify what it is we want to import. So import say hi. Import say hi. So once more, to select what we want to import, we use the from keyword. So we say here from the module name, import specifically only say hi, and the results of that we save in the namespace any3. Okay, and if we run this, we get an error here again. So this time the error is because we have imported say hi, and now we are referencing the function itself. So we now give the name of any3 to say hi. So any3 becomes the name of the function that we've imported. So in other words, we import from class animal3, we import the say hi method, but then we bring it into our space as any3. Of course, if we omit this, then we won't be aliasing say hi, and then we can just use say hi like so. Right, so that's how we can import specific elements from a module. There is this other mention here that further to the comment about relative paths, if we don't want to reference, if we are operating in this folder, and let's say it's not the case that the repository is sitting inside in a subfolder of our current folder. Let's say the repository we want to access is sitting off that path. Let's say it's in a subfolder here, and we could have another folder called repos. Then this example is just showing that we can also, in terms of relative paths, we can jump one level higher towards the parent. So when we append our paths, we can also include directories higher up in the tree, and we can reference other folders that are higher up in the tree. So if we get more specific here in the path that we include, then all those other directories and all the files in those other directories, all those modules become accessible here. So you can get creative with your pathing here. Right, so that's it. That's how we can provide an alias for the module, and how we can reference a module in another folder, and how we can selectively load out of those modules. Now, as useful as all that is, it's still the case that we may need to access a module that is not code that currently resides on our local machine. So we are working on some device, and that device may or may not have a module that we are interested in. So to say it another way, we've been doing our research on the problem we are trying to solve, and there's some specific functionality that may be in some very niche area, and that doesn't come with the distribution that we've been using. So there are many libraries that come bundled with the distribution that, for example, in Anaconda, definitely you'll have the modules like NumPy, SciPy, Matplotlib, and so on. And we'll go through those libraries in future videos. But there may be some other libraries that are not there in your distribution. And of course, modules are coming out all the time, right? That's the beauty of operating with the open source community and operating with modules, that people are constantly working on new problems. And we want to be able to tap into that community and bring those other modules into our environment. And the way we do that is by calling up the global repository, and we do that via pip install. So for example, if we wanted to create a MySQL database, then the way we would do that is through pip install, and that would be in our command window. So if we go back to the command prompt here, right, and I'm just going to break this, so interrupting, and let's just clear that. And so let's say we wanted to use the MySQL module, and we know it's not installed on this on the device that I'm using here. So the way I would install it is to say pip install MySQL, and so the system will go and look up MySQL, and will go ahead and install it for me. Right, so you can go ahead and install as many modules as you like, and you can import them into your Python code or into your Jupyter notebooks. We will be going beyond Jupyter notebooks in some upcoming videos, so we'll be looking at something closer to the production environments that we mentioned earlier. We'll be looking also at how you can deploy your code to the web and things like that. For now, we'll be focusing on some of the more important modules out there, especially NumPy. So the NumPy library is really what facilitates our vector matrix operations. It also hosts a number of mathematical operations, things that we mentioned earlier, things like the transcendental functions, which are not in Python by default. So NumPy really contains many, or it gives us the facility to undertake many of the operations that we expect, and also it does all the vector matrix operations. SciPy helps us with many of the higher level operations, so helps us do things like integrate equations, solve for the minimum of functions, and so SciPy helps us work more on functions. Matplotlib, as the name suggests, it helps us with plotting and visualizing our results. And then it's not really typical, but I like to use SymPy as well. So symbolic math is possible in SymPy. So those are just some of the modules that we will review, and really today those are some of the sort of entry-level modules. So to really claim we can do anything in Python, we should be familiar with at least those modules.